Hello, ladies and gentlemen. I wanted to take a little time to do a few examples of the balancing problems when you're given the names of the substances to help you guys work on breaking down the sentences and identifying the correct things. The advice here is to help you break apart and interpret the question so that you can get the right information in the right order. What I would recommend is identify the substances in the reaction and annotate it. Put a box around it. This would be like using our vocab step of the analyzing the prompt. The next step, we have to write the correct formulas using subscripts only. Then lastly, we'll balance the equation using our coefficients. So when we do formulas, I shouldn't see any large numbers, and when we balance the equation, we shouldn't be messing with the formulas that we wrote. Now, this question is number 2 from the back page of the original introduction packet. These are the ones that are written out as sentences, which are the most complex to break apart. So following my steps, first I'm going to identify my substances. Potassium chlorate, when heated, produces, okay, that would be our change, potassium chloride and oxygen. So the biggest thing here is being able to pick out the actual substances. Now I'm going to create my formulas. Well, potassium is a group 1 metal, so it's a +1 charge. We're dealing with ionics. And chlorate is a polyatomic ion. The 8 is our hint of that. If you look on the back of your sheet for the periodic table, you'll see it's a -1. So that formula is KClO3. The ClO3 is our chlorate ion. When heated, produces potassium chloride, so that's a +1. Chlorine is a group 7. That means it only needs one more electron to be stable, giving it a -1 charge. That's going to make KCl, because they cancel out already. And oxygen. Now that's elemental. Normally we would just put O, but because that's one of our Hofbrinkel elements, one of our elements that's diatomic, ooh, super tight, okay, that's going to be an O2. So I've just finished the second step where I've written the formulas. My last step now, and we'll do this with a different color, is I have to balance the equation. I'm going to show the charting method just to make sure that we get a little bit of practice with that. So I have 1 K, 1 Cl, and 3 oxygens on the left. I have 1 K, 1 Cl, and 2 oxygens on the left. So here we see oxygen is the only thing I can work with. Now there's nothing I can multiply a 2 by to get a 3, so I'm going to have to set them both equal to the same thing. The smallest number I can do that with is 6. So I'm going to multiply over here on the right the O2 by 3. That's going to give me 6 over here. And then I'm going to multiply the KClO3 by 2 to give me 6. But then that also changes my Cl and my K. So I'm going to go back here and change my K and Cl to be balanced. Okay. So next problem, last one for this video. Let's get back to my other color so we can do that the same way. We are going to have ammonium phosphate. Now solution simply means it's a mixture. That's like the ones I did in the demo where we said it's dissolved in water. And barium chloride, so the and, that's my plus sign. These two things are being mixed together. Makes, that's my arrow. These two things are making something else. Barium phosphate. Precipitate just means it's the solid. And ammonium chloride solution. So our ammonium phosphate, those happen to both be polyatomics. Now remember, ammonium is our only positive polyatomic. The ammonium is a +1, and the phosphate is a -3. So if I have to cancel out, I'm going to need 3 of those to cancel out the -3 charge of the phosphate. Now because it's a polyatomic, I need parentheses. Remember, the NH4 is a chunk you can't split up. So if I want 3 of those, I got to show that all together. and then my phosphate is PO4. Plus barium chloride, the barium is a group 2 metal, so that's a +2. Chloride from the last example we saw as a -1. I'm going to need 2 of the chlorines to be able to cancel that out. So we have BaCl2. Then we already have our charges from last time. We have a +2 and a -3. Think about your crisscross rule. Ba3 PO4 2 plus, we have our +1 and our -1. That one will be nice and easy. NH4Cl. Now, when we go to chart, this is a really good one to do the charting for because there's a lot of parts going on. Notice that the NH4 stays the same on both sides. That means I can keep it together as a chunk. I'm going to put that together in the list. Same thing for the PO4. That's going to make this a lot more manageable. Then Ba and Cl are separate. Remember to write in your charts the things in the same order from top to bottom. It'll be a lot easier to visualize as you look left to right. Let's see, so I got 3 NH4s, 1 PO4, 1 Ba, and 2 Cls. Over here, I have 1 NH4, 2 PO4s, 3 Bas, and I've got 1 Cl. So normally we would start with our metals, and I think that's a good place to start today. The metal we have is the barium, so I'm going to start with that. If you look on the right, I've got 3 of them, and on the left I only have 1, so I'm going to multiply times 3. That's going to give me 3 Bas, but also 6 total Cls. 3 times 2 is 6. Now, the next thing I can look at, I notice my PO4s are out of place. Our ions are the next thing to look at. So I see 2 PO4s on the right. I'm going to multiply by 2 on the left. That's going to give me 2 PO4s, but also now 6 NH4s. Well, that's another polyatomic ion. Let's go ahead and take care of that one. I have 6 on the left right now and only 1 on the right. So I'm going to multiply that by 6, changing that to a 6, which is convenient because that made my Cl a 6 as well. As I look across, 6 and 6 for the ammonium. I've got 2 and 2 for the phosphates. I've got 3 and 3 for the bariums. And 6 and 6 for my chlorines. So we are all set. Remember, when it's difficult to break it down, the best advice I can give you is make notes in the problem, especially putting your charges up at the top because it's going to keep it away from your final formulas, which could make them wrong. Ionic compounds, the whole point of them is that they cancel out the charge, so you're not going to see the charge in the actual final formula. Remember to email me with questions if you have them.